All right. So we've gone over the rules for the derivatives. Now, but we've only been working with we've only been working with polynomial functions, right? What's going on? Okay. Today we're going to apply those derivatives, but now we're going to talk about trig functions. So you know that polynomial functions like x squared, x cubed, and all this stuff, that's just like one tiny little class of functions. There are exponential functions, trigonometric functions, logarithmic functions. We're going to learn how to find derivatives of these, one by one. Today we're starting with the trig functions. Now, if on the test you have to find a derivative, okay, then watch for, does it ask you to find the derivative using the definition, which is the limit as, h approaches 0 of f of x plus h and so on. So do you have to use the definition, or can you just do the shortcut, the power rules and stuff? All right, so one of the rules we're going to learn today is it has to do with derivatives of trig functions, okay? The very, very first one that we're going to learn is the derivative of sine of x, and that's just cosine of x. All right? And then the derivative of cosine of x is negative sine of x. So if you have sine of x, you take a derivative, you get cosine. You take a derivative, you get negative sine. You take another derivative, you get cosine. So it alternates back and forth, back and forth. Now, these two in that box, the derivative of sine and cosine, you just have to memorize it, okay? There is no other way to do it. You won't be given the formulas on the test, so you just have to memorize it. Luckily, it's not that difficult to memorize. Yes?
Now, when we're going over everything, can you write down a list of things that we do have to memorize so that we know?
Well, yeah, we can go over some stuff tomorrow. Yeah. All right. So this you have to memorize. Oops. Okay. All right. So take a look here. We have to find the derivative of this. And what is our function? It's x squared times sine x. So look here. You have two different functions being multiplied by each other, right? So you have x squared and you have sine of x. And they're being multiplied by each other, so you have to use the product rule. Do you remember the product rule? Product rule, remember that was u v prime plus u prime v? That's the quotient one. This is just the first times derivative of the second plus the second times the derivative of the first, right? Where was that? Here. Okay? So that's what we're going to be using over there. All right, so let's do that one. Remember, the first function is u, and the second function is v. So this is u, and this is v. So y prime is the u, which is x squared.
Wait, y prime also means
dy dx. Yeah. So it's u v prime plus u prime v. All right, so it's u, which is x squared. Now v prime, which is what? The derivative of sine, which is cosine x, plus, now we need u prime. What's the derivative of u prime? 2x times v sine x. Okay, and that's actually it. I'm just going to write it over without the dot. Yeah. I know it does. It doesn't look clean in any way, but this is it. Okay?
Wait, what's the difference? Why did you write it?
I just took away the dots, that's all. You don't even have to.
Oh, sorry, I can just
Yeah. Okay, so this next one is a quotient one, right? So you have, this is your u, and this bottom one is your v. This is the one that you're going to do low, d, high, and so on and so forth. So this, the bottom one is the low, and this one is the high, right? So y prime, it's going to be a fraction, all right? And it's low d high. So 1 minus sine x times the derivative of the higher one, which is negative sine x. Take high d low, so it's cosine, times the derivative of the low. What's the derivative of the low? The derivative of 1 will be 0 minus cosine x. Negative sine x was the derivative of the high. So it's low d high minus high d low over the lower one squared. Okay? All right, but this we need to simplify a little bit. So let's simplify. So y prime is equal to, all right, I'm going to distribute the negative sine x. So we're going to get negative sine x plus sine squared x plus cosine squared x. Everybody with me? Over 1 minus sine squared x, 1 minus sine x squared. Okay, pre-calc people.
Does it matter when you put squared? Is it the after the x?
It does matter. Sine squared x and sine x squared are not the same. What equals 1? Yeah. Sine squared x plus cosine squared x equals what?
1.
Equals 1. That's That's from chapter 5. 5.1, Pythagorean identity. Okay. Okay. Everybody together, repeat after me. Sine squared x plus cosine squared x equals 1.
Sine squared x plus cosine squared x equals 1.
You need to know that like you know your name. Okay? Nope, not that one. That's a sum and difference. This is one of its own. Huh? This is one that you can't get away with without knowing. Okay? So now we have negative sine x plus 1, right? Over 1 minus sine x squared. What do you notice? What's negative sine x plus 1? Are they opposite? They're totally the same thing. Look, negative sine x plus 1, if I just switch the order, it's 1 minus sine x, is it not? So 1 goes cancels with 1, so I have 1 over 1 minus sine x. 1 from the top cancels with 1 from the bottom, so this is the answer.
Why do you just not like do factor?
Factor what?
Not factor, but like
Multiply it out?
yeah, the bottom. Like
Well, because if I do that, then I wouldn't have been able to cancel like this, right? That wouldn't be that wouldn't take us down the right path.
So you usually just not simplify the bottom.
You have to see each case on its own. Sometimes you do, sometimes you don't. You just have to see what will take you a step further. Okay? All right? So when you're doing these, so what we learned that was new today was the derivative of the sine and the derivative of the cosine. Aside from that, the procedure was not new. It was from 3.3. Okay? So the product rule and the quotient rule, this was not new. So when you see a problem, you have to look at what you have. Now that we've introduced the trig functions, the one thing you have to watch out for is this, what type of function is this? Does this have trig and polynomial mixed with each other? Most of the time, okay, you're going to have a product rule or a quotient rule. Otherwise, it's too boring of a problem, okay? Now, where is this used? So you know what a cosine wave looks like. You know what a sine wave looks like. They pretty much look like this, similar. And if the derivative so remember, if the derivative is velocity, okay, and acceleration and so on. So sine and cosine, they oscillate back and forth, right? It's positive, then negative, and positive, then negative, and positive, then negative. So think about what would have velocity that would oscillate back and forth. Positive velocity, negative velocity, positive velocity, negative velocity. A sound wave or like a physical object. Okay, like if you had a ball bouncing up and down, for example, right? The velocity is positive when it goes up, negative when it goes down, and so on. An even better example is if you have a spring, right? So if you have something like this, if you have a spring and a weight tied to the end of the spring, if you pull the spring down and let go, what would happen? It would oscillate back and forth, back and forth. So when it's moving in one direction, it's got positive velocity and then negative, and then positive and then negative. That's like a sine wave or a cosine wave. The velocity is positive, negative, positive, negative, positive, negative. Why I'm saying this is that one of the best applications of this is what we call simple harmonic motion. All right? Simple harmonic motion is the name for the motion of a weight, okay? Basically, going up and down at the end of a spring, okay? All right, so let's take a look at this example. You have a weight hanging from a spring, okay? Now, if you hang the weight there and you just sort of like, you bring it to equilibrium, you make sure it's not moving, and you just leave it like that, and it's standing still, that height where it's standing still, we call that what? We call that either the rest position or the equilibrium position. So we call it the rest position. Okay? When it's not moving, when the spring is like in equilibrium, it's not being stretched or condensed. So that's the rest position. And then when you pull it down from the rest position, it's going to keep oscillating above and below that rest position. Okay? So take a look at this. This in the middle is the rest position. Okay, that's the rest position. So weight is stretched 5 units below the rest position. So at t equals 0, it's here. And then it's released to bob up and down. Its position at any later time t is s equals 5 cosine t. What are its velocity and acceleration at a time t? So if this is s, if you're given s, how would you find v of t? Take the derivative. So it would be what in this case? Negative 5 sine t. Questions? Cosine. Oh, sorry, I'm sorry. It's 5 cosine t. So the velocity is negative 5 sine of t. And then what about the acceleration? So the derivative of cosine is negative sine. Yeah. Okay, so it's like this. It's 5 times something, right? That's the coefficient. So it'll be 5 times. So imagine if you had 5x squared and you wanted to take a derivative, right? What would happen? The 2 would come down. So you have 5 times 2 times x. Okay, so the coefficient stays. And now you take a derivative of the cosine.
But if it were to be 5 plus, would it just be...
Yes, then it would be 0.
Why is it negative, not 5?
Because the derivative of cosine is just negative sine. That's the rule. So the velocity is negative 5 sine of t. And then what would the acceleration be?
Do you have to switch it back to the second derivative?
No. What do you mean switch it back?
Do you have to switch it back to the second derivative to technically the negative sine of t, would it go back to cosine?
No. Yes, it would go back to cosine. So now it's negative 5 times the derivative of the sine, which is cosine of t. The a of t? Okay, so velocity is this. Okay, now I want to take the derivative of that to get acceleration. So it's negative 5 times the derivative of sine. So that's negative 5 times cosine. Okay? Any other questions? Yes. Oh, sorry. Any other questions? That's all for that problem. Yeah.
Why wouldn't the 5 just be 0? Because, like, there's no x next to it, so, like,
Okay, so that's what I was explaining before. If you have 5x squared and you wanted to take a derivative of this one, what would happen? The 2 would come down. So you have 5 times 2 times x. So it's 10x. Well, it's the same thing here. It's 5 cosine of t. So it's 5 times the derivative of this, which is negative sine of t. You would if it was 5 plus cosine t. Okay? Okay? Yes, now.
So after you do that and find the acceleration, then you find the derivative of sine again. Then you go back to cos.
Well, so what happens is we started with s, right? That was cosine, right? So now, in order to find velocity, I have to take the derivative of this. The derivative of cosine is sine, negative sine. Now I need to take the derivative of sine. What is the derivative of sine? It's cosine. So with sine and cosine, if you look here, the derivative of sine is cosine, and the derivative of cosine is sine. So if you keep taking derivatives, you're just going to go back and forth, back and forth, back and forth. Okay, so if I start, okay, so if my function is, let's see, suppose my function is sine of x, okay? And if I find f prime, then that would be cosine of x. Now what about f double prime? Negative sine of x. Now what about f triple prime? Negative cosine of x.
Why is it double negative?
Well, I'm sorry. No. Sorry. Negative cosine of x. Now, what's f?
Negative.
The fourth derivative. It's negative sine x, which is sine x. And then if I wanted to take the fifth derivative, right? It's going to be cosine x. And then the sixth derivative, negative sine. So it just keeps going back and forth with some negatives in there. Okay? Yeah.
If you know the derivative of cosine and sine, they're the opposite, how would you know the derivative of cosine?
That's what we're going to do now. So, wait a minute. Okay, so let's do this. So the other ones can be derived using the derivative of sine and cosine, right? Okay, let's find the derivative of tangent. What is tangent? There we go. Okay, so rewrite. Oops. Y equals tangent of x is y equals sine x over cosine x. Okay, what rule can I use for this? How do I take the derivative of this? Quotient rule. Okay, quotient rule. High D low minus low D high, right? So y prime is going to be high. And what's the derivative of the low?
Negative sine of.
Minus low D high over cosine of x squared. Okay? So, what do I have here?
Negative sine x squared minus
Right?
why don't you put cosine first because low
Oh. Say that again?
Isn't it low d high takes high d low? So when you put
It is. I'm sorry. I'm sorry. I'm sorry. My mind just wandered. I'm so sorry. Thank you. So, low D high, what would that be? Cosine times cosine minus high, the derivative of the low. Okay, so what do we have now? Cosine squared x plus sine squared x, right?
Oh, that's 1.
What is that? Yeah. That's 1 over cosine squared x. And what is 1 over cosine?
No, it's
Secant. So this is secant squared x.
Wait, how did you? Oh, it's the. How did you know that it was secant?
How did I know that it was secant? 1 over cosine is secant. That's just how they're defined. Yeah.
But only if it only.
So therefore, ddx of tangent x is secant squared x. Okay? Huh? Huh? Yeah. I mean, no, I'm just saying, like, that's the derivative. So now, with similarly, you could find all the other derivatives here. Yeah. So we need the equations for the lines that are tangent and normal to the graph of blah, blah, blah. So how do we find the equation of the tangent line? You find the derivative at x equals 2, okay? So for the equation of the tangent line, we need to find the derivative. We need to find the derivative at x equals 2. That would give us the slope at x equals 2. And then we go from there. So let's go slope. So to find the equation of a line, you need a slope and a point. The slope, okay, we have to take a derivative and plug in 2. Okay? So let's do f prime of x. All right, so we're going to take the derivative of this. So this is the low, and this is the high. Okay, so what's going to be the derivative? Low d high. So what's that? Squared x. Right, and then minus high d low. 1 over x squared. Okay? Yeah.
I don't know if you said this, but we need to memorize all of those.
Yeah. Yeah. Okay, now take a look at this.
Is there like a way we can? Like, does it make sense somehow?
I see what you're saying. Well, I mean, the thing is, like, for secant, it repeats. Like, for secant, it repeats. Like, it's secant x tangent x. And cosecant, it repeats. Cosecant, cotangent. Right? And so secant doesn't have the cos, and it's just the same thing times the tangent. The cosecant has the cos, so it's the same thing times the cotangent. Cosecant, cotangent. Secant, just tangent. And then, right? I'm running out of time, so let me do this, okay? All right, so now what we really want is f prime of 2. Okay? Because we need the slope at x equals 2. Not really, because you're going to plug in a 2, right? You really need a numerical value. Okay? So what I want is f prime of 2. So all the x's are going to be 2's. So 2 times secant squared 2 minus tangent of 2 over 2 squared. Okay? Now you're going to plug it into the calculator. Now hang on. F prime of 2, listen. So on the bottom it's 4. This one, 2. To plug it into the calculator, there is no secant button. So it's going to be 1 over cosine 2 squared.
Do you use degree mode or
Radian. Okay? Minus tangent of 2.
wait, is it cosine 2 squared or cosine squared 2?
Okay, it's, I'll show you how to plug it into the calculator. It's cosine squared 2, so basically it's cosine of 2 parentheses squared. Mm-hmm.
Oh, so this would be in the calculator section? Isn't the whole thing calculated?
It's in radians, right?
Yes, radian. Okay, so right, so it's going to be 2 times 1 over cosine of 2. Okay, now we close everything squared. Minus tangent of 2. Okay, divided by 4. All right, so it's 3.433. Now, we're going to go to 3 decimal places. So this is going to be 3 point. I know. I'm fine. Go ahead.
You accidentally put the 2 inside. Now you have to put double parentheses at the end.
This 3.433, this is the slope of the tangent line. Okay? So we said earlier that we needed a slope and a point. We have a slope. To get the point, right, we need f of 2. So f of 2, that's f of x is tangent over x, right? So f of 2 is tangent of 2 over 2. And if you plug that into your calculator, it's negative 1.093. Now, let me do the slope, let me do the equation of the tangent line. It's going to be y minus negative 1.093 equals to the slope x minus 2. And we don't do minus minus, so it's going to be y plus. This is the equation of the tangent line. Okay, now I need to find the equation of the normal line. If 3.433 was the slope of the tangent line, the normal is negative 1 over, right? So the normal slope equals negative 1 over 3.433, which is negative 0.29. So the normal line, huh? No, no. We never, ever, ever put a decimal inside a fraction. That's not good form at all. So you can never do like 3.4 over 5, okay? So it's going to be y plus 1.093 equal to 0.29 negative x minus 2. That's the equation of the normal line. Yeah, both of these are point slope form. Okay? Well, because the point through which it's passing is the same, it's just the red is perpendicular to the blue. Okay, here we're given y, and we need to find y double prime. Okay, if y is secant of x, y prime is secant x tangent x. Okay? So now, to find y double prime, what property am I going to have to use? Which one? The product rule, right? So that's going to be uv prime plus u prime times v. So that's going to be secant times tangent x, the derivative of tangent x, which is what? Secant squared x, plus u prime, the derivative of secant, which is secant x tangent x, times v tangent x. You just have to be careful. Honestly, like most mistakes will, they'll be because your mind is somewhere else. Just like I made a mistake earlier because my mind was somewhere else. So y double prime then is secant cubed x plus secant x tangent squared x. Okay, now, so somebody will ask me, do you need to factor out a secant? Not really, because it won't get you anywhere. All right? Tangent squared x. So secant cubed plus secant times tangent squared. Okay? And this is due tomorrow.